Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to learn how to form or create esters through this reaction or process known as esterification. Before we get into the details of esterification, I want to quickly go over some of the key features of this new functional group. And so esters belong to the carbonyl family, meaning that it has this distinctive carbonyl group embedded in its structure. And so this carbonyl group contains a carbonyl carbon that's sharing a double bond to the carbonyl oxygen. Now, what makes this carbonyl group an ester is that the carbonyl carbon is covalently bonded to an R group, and it's covalently bonded to an oxygen that is itself covalently bonded to another R group. And so these R groups represent any alkyl chains. And so these R groups can be the same or they can be different. And so what we're looking for with respect to esters is we are looking for a carbonyl group such that it is covalently bonded to an oxygen and it is covalently bonded to another carbon chain, whatever this carbon chain is. And on the left-hand side of the carbonyl carbon, it's going to be covalently bonded to another carbon that's going to be connected to another alkyl chain. And so what we're looking for when we're trying to identify or classify this specific functional group is this COC, so it's reminiscent of an ether, but instead of it being an ether, we have to include this carbonyl group. And so this whole thing that I'm circling will represent our ester. All right. And so we're going to go ahead and take a look at one example of what an ester might look like. And so here we have this ester compound in which we have the carbonyl carbon covalently bonded to this oxygen that's covalently bonded to this methyl group. So notice that we have a distinctive pattern in which we have the carbonyl group, and then we have that O and C. Okay, so that whole area is going to be our ester. And so I want you guys to notice that this methyl group is going to represent the R group here. And whatever is in black is going to represent, oh no, it's stuck again. It's going to represent another R group. That could be the same, or it could be a different alkyl chain than the one in blue. But in this case, it's different. And so now that we know the features of an ester, let's go ahead and talk about how esters are formed or how esters are created. And so one way to produce an ester is to take an organic compound that contains a carboxylic acid and react it with another organic compound that contains an alcohol or a hydroxyl group. And so in the presence of this sulfuric acid catalyst, or just a strong acid that will act as a catalyst, the hydroxyl group and the hydrogen of the OH in the carboxylic acid and the hydrogen in the hydroxyl group, they're going to combine together to form water. And so, in a sense, we can think about this as a dehydration reaction. And when this OH is gone, that's going to allow the OR, this oxygen that's covalently bonded to another alkyl chain, to be covalently bonded to this carbonyl carbon. And so, just so that you guys can understand how this reaction works, I'm going to go ahead and redraw it. So you can see how the electrons kind of change during this course of the chemical reaction. It's not the exact mechanism, but hopefully it'll give you guys a better understanding of how this works. So if you guys recall, a single bond is composed of 2 electrons. And so during the course of this dehydration reaction, even though this is not the exact mechanism, the single bond is going to be destroyed, if you will, allowing these pieces to rearrange amongst themselves so that the hydrogen from the hydroxyl group from the alcohol is going to form a covalent bond to the OH group in the carboxylic acid. And so this gives this OR prime an opportunity to form a covalent bond with that carbonyl carbon. And so the product that we're going to get is an ester and a water molecule. Okay. And so we're not focused on the exact mechanism of esterification. We just need to know that if we have a carboxylic acid and we have a hydroxyl group from our alcohol organic compound, when they come together in the presence of an acid catalyst, they're going to form an ester and water molecule. And so the example at the bottom, instead of like putting in R groups and stuff, it's showcasing a specific number of carbons. And so here we have 1, 2, 3 carbon compound. And since this is a carboxylic acid, we know that the name of this organic compound is propanoic acid. Here, this alcohol it's a 1 carbon alcohol. So this is methanol. So we have methanol reacting with propanoic acid. So when the hydroxyl group in the propanoic acid and the hydrogen from that methanol, from the OH in the methanol, are kind of aligned with each other, both of these guys are going to form a water molecule, allowing this OCH3 to be covalently bonded to the carbonyl carbon. And the product that we would get is basically that OCH3 from methanol is going to be covalently bonded to this carbonyl carbon. And then here we have water molecule as a byproduct. And so in short, without going through the exact mechanism of this chemical reaction, we can just go ahead and imagine that the OCH3 will replace the OH, and that OH just gets converted into a water molecule. So feel free to use your imagination to understand, to kind of associate how the products will be formed from these reactants. Okay, again, this is not this is not the full year of organic chemistry, and so as long as you can somehow understand how these substances come together and react to produce the product, and if you guys can replicate that over and over and over again, then you guys are pretty good in terms of predicting the products for an esterification reaction. Yeah. And so here's a couple more examples. Here we have ethanoic acid. This is a 1,2 carbon organic compound that has a carboxylic acid functional group. Here we have methanol. It's a 1 carbon alcohol. And so in the presence of sulfuric acid or a strong acid in heat, our ester will be formed and a byproduct of water will also be formed. Here we have benzoic acid, and it's also reacting once again with methanol in the presence of sulfuric acid or a strong acid in heat. We get methyl benzoate, which is going to be our ester, and we also get water. And so this part right here is going to be the ester functional group. And so what we're going to do is we're going to go through these examples and we're going to predict or draw the product. And so I have a carboxylic acid reacting with an organic compound that contains an alcohol. And so what might the product of these two reactants be? My screen is stuck again. Okay. And so what I want to do is I want to redraw reactant 2. And what I want to do is I want to flip it, or basically turn it 180 degrees around the vertical, so that the hydrogen and basically the hydroxyl group here faces the OH in the carboxylic acid. And so notice that the line is going to go down, so this line is going to go down, and this line goes up, and so this line goes up. And then here I have a methyl group, so I'm going to put a methyl group, and there's another methyl group going down, so I'm going to put another methyl group going down. So what I'm basically doing is I'm drawing its mirror image. And so if this is our product, then according to what I learned in the previous slide, when the esterification reaction occurs, when this is treated with a strong acid, that's going to allow the OH in the carboxylic acid and the H from the alcohol group to combine to form water. And so what I'm going to get is a link between this carbonyl carbon to that oxygen. And so the product that I would draw, first of all, water. And so when it comes to the ester product, I'm just going to go ahead and copy only this portion right here. So I have H, C, double bond O. Okay. So I'm not copying this portion because remember that it now becomes the water molecule. And since the bond is made between the carbonyl carbon and the oxygen in the alcohol group, that means that my product is going to have this oxygen, And then notice that this oxygen is going to have a carbon. So this is 1, 2, 3 carbon chain. So this oxygen needs to have a 1, 2, 3 carbon chain. And then on the, just to do it again, this oxygen is 1, 2, 3 carbon chain. And then on the second dot, if you will, it's going to have another carbon. And so on the second dot, I need to have another carbon. Okay. And so notice how my product, the way I drew my product, it's basically upside down. So this is right side up, this is upside down. And that's okay. It's the same exact structure, and I can flip this, I can rotate it upwards, and I can get the original structure and vice versa. And so as long as the number of carbons that you guys are putting down are correct and the links are correct, then you guys will get the right, you guys will be able to draw the correct product. And so here in this case, this is going to be our ester. So let's go ahead and take a look at the next example. I have my OH and I have my carboxylic acid. And so once you recognize that you have those two functional groups that you're trying to combine, this is automatically going to be an esterification, where in the presence of a strong acid and heat, well, I guess I'll just write heat here. And the source of the strong acid is coming from sulfuric acid. So in the presence of a strong acid and heat, we're going to take this alcohol and it's going to react with the carbonyl carbon, forming water and the ester. So I'm just going to go ahead and draw the alcohol's mirror image. So I'm going to rotate this 180 degrees. So I have my OH, C, H, and H, and H. So I'm just drawing its mirror image. So now that my OH is in line, or it's facing the OH from the carboxylic acid, I'm going to go ahead and draw a circle between the OH of the carboxylic acid and the hydrogen of the alcohol. And I'm going to commit that as water. And so that will tell me that the carbonyl carbon and the oxygen of that alcohol will be attached to each other. Okay, so if I were to draw my product, and I'm going to zoom out, I know that I'm going to have a water molecule plus, now if I were to draw this, I'm going to go from left to right. So this is 1, 2, 3, 4. So I have a 4 carbon chain on my carboxylic acid, and therefore I'll have a 4 carbon chain on the left side of my ester. So 1, 2, 3, 4, and I'll connect them. Okay. And so on the 1, 2, 3, 4th carbon, I have the double bond to the oxygen. So since this is the 4th carbon, this is where the double bond to the oxygen will be at. And on the 4th carbon is where I'm going to have that link to this oxygen. So I'm going to draw a covalent bond that will link the 4th, quote unquote. It's not exactly the 4th actually. I'm just using the number 4 as a reference point since I'm going from left to right. And so the carbonyl carbon is going to be covalently bonded to the oxygen of the alcohol. And then looking at looking to the right of that alcohol, I have this CH3. So that's what I'm just going to draw. So to the right of the OH, I'm sorry, to the right of that oxygen that's now covalently bonded to the carbonyl carbon, I'm going to put CH3. And so if you guys want to draw out the CH3 in the expanded form, that's absolutely fine. If you guys want to, oh, what's going on? If you guys want to write it in terms of a condensed structure, that's absolutely fine. If you guys just want to do it like a skeletal structure, this would be the skeletal structure of CH3. Okay. And so all representations that I've quickly shown are correct. So you guys can just style it however you want. And this would be our product. All right. And so looking at this, notice that my carboxylic acid is on the second. It's not typically on the left-hand side like how it was in the previous two examples. It's now on the right-hand side of that plus sign. And so same idea, you can go ahead and take this alcohol and flip it. And so here, I'm going to make sure that my alcohol of this 2-carbon compound, so this is actually ethanol, is just going to be flipped 180 around the vertical. And so I'm going to have a 2-carbon chain. So here's oxygen, 1, 2 carbons, and then there are hydrogens surrounding those carbons. And you just want to add enough hydrogens so that it is saturated. Okay. And so now that I've flipped my alcohol, notice that I have the correct number of carbons, correct number of hydrogens, correct number of oxygens. I can go ahead and perform this esterification on paper by circling the parts that will make the water molecule. And so in the presence of, once again, the strong acid and heat, we will get an esterification reaction between an alcohol and a carboxylic acid. And so sometimes I'm kind of neglectful in writing my reagent. So I just wanted to bring this up once again. All right, so when I'm drawing my ester product, once again, I just want to make sure I'm copying everything down correctly. So 1, 2, 3, 4. On the 4th carbon, I have the carbonyl. On the 4th carbon, that's going to be bonded to the oxygen. So let's go ahead and quickly do that. And so I have 1, 2, 3, 4. The 4th carbon has a carbonyl. And so the 4th carbon will be bonded to this oxygen. Oops, wrong pen. And then now that I'm here, I'm going to draw this part in. And so once again, since this is an expanded form, you guys can represent the expanded form as a skeletal structure, which is simply this. So this is a CH2, this is a CH3. Now if you guys wanted to draw the actual carbons with the hydrogens, you guys can. So here's carbon, carbon, boom, boom, hydrogen, 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 hydrogen. Just takes a long time. And so if you guys want to write that expanded structure, you guys can. It means the same thing. If you guys want to do the condensed structure, You guys can as well. For me personally, I prefer the skeletal structure because in 2 lines I'm done. And we also have water molecule as a product. Okay. So last but not least, we have this benzene ring that contains a carbon and then the carboxylic acid. And then we have methanol. So we're going to take methanol and flip it so that way the OH lines up with the other OH in the carboxylic acid. And so if this was treated with a strong acid, and a source of strong acid is sulfuric acid, and heat, then we're going to form a water molecule, so a dehydration reaction will occur, allowing this oxygen to covalently bond to this carbon. So now that we understand how everything's linked up, we can just draw the products. Here I have a benzene ring. Okay. And on this corner of the benzene ring, I have my carboxylic acid. And then this part right here, which is this part, it's going to be covalently bonded to this oxygen. And so here I have an oxygen and then CH3. Okay. All right.